All right, so right now we're going to be talking about behavior of gases. It's a quick hit here. So, first off, we're going to talk about something called Boyles Law. Now, this law says that if you decrease the volume of a container of a gas, the pressure of the gas will increase, provided that the temperature does not change. If you increase the volume and temperature remains the same, the pressure will decrease. In Boyle's law, the temperature must remain the same. Okay? So, what does Boyle's law mean? So, if I took all the air, because remember, air can change shape and volume to fit the container. So, I could take all the air in this room, right, and fit it into a pop can. Now, by doing so, the pressure inside the pop can would increase because I've taken the volume of the container, all right, and I decrease that volume. Therefore, the pressure of the gas will increase because there's more particles hitting the sides of that can at the same time. Now, on the same token, if I take that pop can, right, and it's full of gas, right, or an aerosol can, okay, and I chop off the top, right, all that air, that's air that's compressed in there would release, and it would fill the entire room. Now, the pressure from inside that aerosol can would actually decrease when going from inside the aerosol can to a much larger room like the one you're in right now. Because now there are the same number of particles, but now because they're spread out all over the room, there's less particles hitting the same spot at the same time. So therefore, pressure would decrease. This is all provided that assuming that temperature stays the same. Okay? That's Boyle's law. So, examples of this, we talk about, a syringe, your lungs, a bike pump, right? I can take air, and as I push and pump a bike pump, it takes air from outside and puts more and more air into a closed space, causing the tire pressure to increase. Example for your lungs would be during inhalation, right? When you're breathing in, the lungs expand. The pressure in the lungs decreases. Air flows towards the lower pressure in those lungs. Okay, so your lungs expand, there's less pressure, air rushes in. Here we have another way of looking at this same principle here. Here we have, on the left-hand side here, pulling up increases the volume and decreases the pressure because there's less particles striking. Here, if I push down on a syringe or something like that, I'm squeezing things together. I'm making the volume less, and therefore the pressure increases because there's more particles hitting the sides at one time. Then we have Charles' law. Now, Charles' law says the volume of a gas increases with increasing temperature, provided the pressure does not change. Okay, so what do we know? A particle, okay, as particles start to heat up, what happens to the speed? Right, they increase. Okay, so if I increase the temperature, the particles start to move faster. And therefore, if they were to run into the side of a container, you would have more force. Like if I take, for example, an aerosol can, all right, where you have a fixed volume, all right, it's an aluminum can, it does not move, but I take that aerosol can and it says what? Do not put in open flame, right? So if I take an aerosol can, I throw it into a campfire, what happens to it? Boom, right? Why? Because temperature causes those particles to move faster. As the particles move faster, they strike the side of the container with more and more force, increasing the pressure until the pressure is so great that the can, which is metal and doesn't bend real well, right, just explodes. Okay. Now, Charles' law says that if I increase the pressure, or if I increase the temperature, the particles will still move faster. But if pressure stays the same, okay, in other words, pressure does not change, unlike our aerosol can in the fire example, right? Let's say we have a hot air balloon, okay, where you have this object, right, that this thing that can expand. If I take a balloon and I put it over a flame, like on this picture on the right here, what happens? The gas particles start to move faster, okay, and the volume, the balloon starts to expand, the volume increases because the pressure does not change. Okay? And I can do the same, the reverse, where if I take a hot air balloon, or if I take a balloon and I cool it off, the gas particles move slower. And therefore, because the balloon is flexible, it shrinks down, the volume decreases, and the pressure stays the same. This is an example of Charles' law. And